Right now, SpaceX astronauts are splashing into the ocean like medieval knights, but DreamChaser just made that look completely outdated. While Dragon capsules crash into waves at bone-crushing speeds, DreamChaser touches down on runways like butter. No violent impacts, no rescue boats, no seasick astronauts. Here's the kicker. SpaceX needs 30,000 heat tiles after every flight. DreamChaser? Only 2,000 tiles that last multiple missions. But there's something NASA isn't telling you about this technology. Something that could determine the next space race winner. Let's dive right in. Picture this moment. February 1st, 2003. Columbia is screaming through Earth's atmosphere at Mach 25. Inside the shuttle, 7 astronauts have no idea that a briefcase-sized piece of foam struck their wings 16 days earlier during launch. That foam punch created a hole, a tiny hole that became a death sentence. At 2,600 degrees Fahrenheit, superheated plasma found its way inside Columbia's wing structure. The shuttle disintegrated over Texas. 14 astronauts total would die because of NASA's thermal protection nightmare. But here's what NASA didn't tell the public. They knew the thermal tile system was a disaster waiting to happen. Each space shuttle carried over 24,000 individual heat-resistant tiles. Every single one had to be manually inspected after each flight. Thousands of labor hours, millions in maintenance costs. The real kicker? These tiles were so fragile that ground crews could damage them just by leaning against the shuttle. So why did NASA persist with this flawed design for 30 years? The answer reveals everything about why DreamChaser changes the game completely. NASA promised the space shuttle would cost $10 million per launch. The reality? Each mission averaged $450 million. That's not a budget overrun. That's a complete fantasy. The thermal protection system was the biggest culprit. Those 24,000 tiles weren't just fragile. They were unique. Each tile was custom designed for its specific location on the orbiter. Lose one tile? You couldn't just grab a replacement from storage. You had to manufacture a brand new one from scratch. But the insane part wasn't the cost. It was the vulnerability. During every launch, the shuttle's solid rocket boosters would shed debris. This debris would pepper the orbiter's heat shield with micro-impacts. Ground crews would spend weeks after each mission playing a deadly game of find the damage. Miss one crack, miss one missing tile, you get Columbia. Now here's where this story takes a shocking turn. Because while NASA was spending decades and billions trying to fix an unfixable system, a small aerospace company was quietly solving the problem with technology that would make those 24,000 tiles look like Stone Age engineering. Sierra Space looked at NASA's thermal protection nightmare and asked one simple question. What if we built tiles that actually worked? DreamChaser uses just 2,078 tiles compared to the shuttle's 24,000 plus. But these aren't just fewer tiles. They're fundamentally different beasts. Each DreamChaser tile measures 10 inches by 10 inches, nearly 4 times larger than the shuttle's 6 by 6 inch tiles. Larger tiles mean fewer joints. Fewer joints mean fewer failure points. Fewer failure points mean fewer dead astronauts. But size isn't the revolutionary part. It's the material science breakthrough that changes everything. While shuttle tiles could barely survive one re-entry cycle before requiring replacement, DreamChaser's tiles are designed for multiple missions. The standard tiles can withstand temperatures up to 2,600 degrees Fahrenheit across multiple re-entry cycles. This isn't just better engineering. This is the difference between a Ferrari and a horse-drawn carriage. But wait, there's something even more shocking about these tiles that NASA's engineers discovered during testing. Something that completely eliminates the most dangerous part of spaceflight. Every spacecraft faces the same deadly challenge. The transition from the vacuum of space to Earth's thick atmosphere creates temperatures that would vaporize steel in seconds. But here's what makes DreamChaser different. Unlike SpaceX's Dragon capsule, which plummets like a rock and relies entirely on parachutes and ocean impact absorption, DreamChaser has wings. Those wings aren't just for show. They provide something revolutionary, control during the most dangerous part of spaceflight, When Dragon re-enters, it follows a ballistic trajectory. That's a fancy way of saying controlled falling. The capsule has virtually no ability to maneuver. If something goes wrong, if the heat shield fails, if the parachutes malfunction, the crew is along for the ride. DreamChaser? It glides like a 40,000-pound glider with the precision of a fighter jet. The spacecraft can alter its trajectory by up to 1,400 miles from its original re-entry path. That means if weather closes the primary landing site, DreamChaser can glide to an alternate runway. If there's an emergency, it can reach multiple landing options. But the real game changer isn't the landing flexibility. It's what happens the moment DreamChaser touches down. When Dragon splashes down in the Atlantic, it triggers a massive recovery operation. Ships, helicopters, specialized crews, and hours of bobbing in ocean swells while astronauts fight seasickness after surviving the trauma of spaceflight. Then comes the real nightmare: saltwater contamination. Every piece of sensitive equipment, every experiment, every cargo item gets exposed to corrosive ocean spray. Recovery teams have to carefully extract everything while the capsule bobs, like a cork. DreamChaser rolls to a stop on a runway, like a commercial airliner. Ground crews can immediately access the cargo bay. No salt water, no recovery ships, no seasick astronauts. But here's the jaw-dropping part. Sierra Space claims DreamChaser can be ready for its next mission within 24 hours of landing. 24 hours. Let that sink in. Dragon requires months of refurbishment between flights. The heat shield has to be completely rebuilt. The parachute system needs repacking. Every system requires extensive inspection and testing. How is this 24-hour turnaround even possible? The answer lies in a design philosophy that's completely opposite to everything NASA learned from the shuttle program. Here's where DreamChaser's design gets truly brilliant. The spacecraft uses a detachable cargo module called Shooting Star. This 15-foot module can carry up to 10,000 pounds of cargo to the International Space Station. But here's the twist: it's designed to be expendable. During the return journey, Shooting Star handles all the station's trash and waste. Then, just before re-entry, it detaches from DreamChaser and burns up in the atmosphere. This solves two problems at once: waste disposal and weight reduction for landing. But there's a deeper strategy at play here. By making the cargo module expendable, Sierra Space eliminates the most complex part of spacecraft recovery: all the messy logistics of waste management, contaminated materials, and heavy cargo handling. Burns up in the atmosphere. DreamChaser lands clean, light, and ready for rapid turnaround. This isn't just smart engineering, it's a complete rethinking of how space operations should work. But it raises a disturbing question. If this technology is so superior, why isn't SpaceX pursuing it? SpaceX chose capsules for one reason. They're simple: no wings to deploy, no landing gear to extend, no runway required. Just a heat shield, some parachutes, and hope for the best. But simplicity comes with a price. Dragon's re-entry is violent. Astronauts experience up to 4 Gs of deceleration as they slam into the atmosphere. Then comes the parachute deployment, another jarring impact. Finally, they hit the ocean at 15 miles per hour. That might not sound fast, but when you're inside a 13,000-pound capsule, it's like getting rear-ended by a truck. DreamChaser's runway landing? Smoother than most commercial flights. Astronauts walk off under their own power, instead of being carried off on stretchers. But the real limitation of Dragon isn't the violent landing. It's the cargo recovery problem. Every Dragon mission requires a small fleet of recovery vessels positioned in the splash zone. These ships cost millions to operate and limit where Dragon can land. Bad weather? Mission delayed. Rough seas? Delayed again. DreamChaser can land at any airport with a 10,000-foot runway. That's hundreds of potential landing sites across the continental United States alone. So why hasn't SpaceX pivoted to spaceplanes? The answer reveals a fundamental difference in philosophy that could determine who dominates the next era of space exploration. SpaceX bet everything on rapid iteration and cost reduction. Build it cheap, fly it often, improve it fast. This philosophy worked brilliantly for getting humans back to the ISS, but it has limitations. Dragon is essentially a 1960s Apollo capsule with modern electronics. The fundamental physics of ballistic re-entry haven't changed in 60 years. Sierra Space took a different approach. They asked, what if we applied modern materials science and aerodynamics to solve the re-entry problem, once and for all? The result is a spacecraft that doesn't just match Dragon's capabilities, it obliterates them in every category that matters for the future of space commerce. But here's what makes this development truly explosive. NASA is betting their entire commercial crew strategy on having multiple providers: Dragon, Starliner, and now DreamChaser. Boeing's Starliner has been a disaster. Multiple failed test flights, software problems, and cost overruns have effectively eliminated it from consideration. That leaves Dragon and DreamChaser. One represents evolutionary improvement, the other represents revolutionary change. But there's something even more significant happening behind the scenes. Something that suggests this isn't just about transportation to the ISS. It's about who controls access to space itself. Sierra Space isn't just building space planes for NASA. They've secured multiple contracts with the Defense Advanced Research Projects Agency, DARPA, for lunar infrastructure development. Why would the military be interested in space planes? The answer lies in something Dragon simply cannot do: rapid, precise landing at any location on Earth. Military satellites sometimes need immediate recovery. Classified payloads require secure landing zones. Time-sensitive experiments can't wait for optimal ocean conditions. DreamChaser can land at Edwards Air Force Base, Vandenberg Space Force Base, or any military runway capable of handling large aircraft. This flexibility makes it invaluable for national security applications. But the military application is just the beginning. The real prize is commercial space stations. NASA's ISS is aging out. Private companies are building replacement stations in low Earth orbit. These stations need regular cargo deliveries, crew rotations, and emergency evacuation capabilities. Dragon works for the ISS because the station was designed around capsule operations. Future commercial stations? They're being designed around space planes. This shift represents a fundamental change in how we think about space access. Instead of expensive, complex recovery operations, space planes enable airline-like operations, regular schedules, multiple destinations, rapid turnaround. It's the difference between 1960s space exploration and 21st century space commerce. But there's one more twist to this story, one that NASA has been quietly preparing for, and it changes everything about the future of human spaceflight. While everyone's been focused on the ISS, Sierra Space has been building something bigger, something that could make Dragon completely obsolete. It's called Orbital Reef, a commercial space station being developed with Blue Origin. But this isn't just another space station. It's a 3-story inflatable habitat that expands in space, providing more living area than the entire ISS. And guess what vehicle is designed to service this station? DreamChaser. The spaceplane's runway landing capability becomes critical when you're dealing with sensitive experiments, delicate manufacturing processes, and high-value cargo that can't risk saltwater contamination. But here's where this gets really interesting. Orbital Reef isn't just one station. It's a platform for multiple commercial habitats, each one designed around spaceplane operations, each one requiring the kind of precise, clean delivery that only DreamChaser can provide. SpaceX's Dragon? It's perfectly suited for the old way of doing space business. Government missions to government stations with government recovery operations. DreamChaser is designed for the new space economy, commercial stations, private customers, airline-like operations. The question isn't whether DreamChaser is better than Dragon. The question is, which vision of space commerce will dominate the next decade? Right now, we're at a crossroads in human spaceflight. One path leads to incremental improvements on 1960s technology: bigger capsules, better heat shields, more reliable parachutes. It's safe, proven, and fundamentally limited. The other path leads to a complete reimagining of how humans access space. Runway landings, rapid turnaround, airline-like operations, and the infrastructure to support a true space economy. DreamChaser's first flight will determine which path we take. If it succeeds, if it proves that space planes can deliver on their promises of safety, efficiency, and rapid reusability, then everything changes. Not just for NASA, but for every company, every country, every entrepreneur with dreams of space commerce. If it fails, then we're stuck with violent ocean landings and multi-month refurbishment cycles for the foreseeable future. But there's something about Sierra Space's approach, something about their methodical engineering and focus on solving fundamental problems, that suggests they've learned from NASA's mistakes. They're not trying to build the Space Shuttle 2.0. They're building the foundation for space transportation that actually works. So here we are, standing at the edge of a space revolution that most people don't even see coming. DreamChaser isn't just making SpaceX's ocean landings look obsolete. It's rewriting the entire playbook for how humans will live and work in space. But here's what really keeps me up at night. While we've been watching this incredible engineering battle unfold, China just announced their own spaceplane program, and they're not building it for cargo runs to the ISS. The country that controls runway-to-orbit operations controls the next frontier of human civilization. So I want to know, do you think America is moving fast enough? Or are we about to watch another Sputnik moment happen in slow motion? Drop your thoughts below, because this story is just getting started. And if you want to stay ahead of the space race, the kind of developments that reshape entire industries before most people even notice, then you know what to do. The future of space isn't waiting for permission. The question is, are you ready to see it coming?